Welcome to my 12th video of engineering thermodynamics, and successfully I have launched 12 videos for the first unit of engineering thermodynamics course, which is a curriculum of second year mechanical engineering students in Anna University, Chennai. Now we have discussed and completed the topics of all the fundamentals and specifically zeroth law of thermodynamics and first law of thermodynamics and various thermodynamics processes for which we have found out the equations for work done, heat transferred and change in internal energy. And of course, we also found out the various applications of those processes, examples, and how why the reactions or the processes and various types of kinds of processes are useful in thermodynamic view. Okay. Now, after completing the concept of first law of thermodynamics for cyclic process and for any process, now we are moving to the application of first law. Okay. Before moving to the application of first law to various thermal devices, first let me explain what is steady flow and unsteady flow process. It is a very interesting definition and topic which is closely related to our application of first law of thermodynamics to various devices. Already I have told you that open system means which allowing both mass transfer and energy transfer into or out of the system is most of the thermal devices are using this open systems. And another one more thing is all these thermal devices are coming under steady flow process only. Either it would be steady or unsteady flow process. Most of the devices are working under a steady flow process only. Okay. Now, what is steady flow process? Okay. When the fluid is moving inside the system from one end to another end or from entry to exit. Okay. The fluid parameters here means in macroscopic approach we are concentrating volume, temperature, density, specific volume and other state identifying properties. Okay, at any point these fluid parameters at any point of the control volume remains constant with respect to time. Okay, that is, remains constant with respect to time means those parameters during that processing time, during the time in which that particular process happens will not change with respect to time. Of course they would be changing their velocity, pressure depending upon the place, but they will not change with respect to time. Okay, so this is the process which called steady flow process. Here if you take if you are representing any property as P means dou P by dou T is equal to 0. That is, property with respect to time, change in property with respect to time is absolutely 0. It is the rate of change of any, here I have mentioned as pressure, but any property at a particular position is 0. It will not change or vary with respect to time. Okay, if the fluid parameters or the values are varying with respect to time means then the flow process could be called as unsteady flow process. Okay. So be clear that the fluid properties or the any working substance properties will not change with respect to time during the course of time of that particular process. Okay, then it is called steady flow process. Here, before moving to again how the thermal devices are correlated with this steady flow process, let me explain two important definitions with respect to this steady flow process or open systems. Okay, open system means they are open to both energy transfer and mass transfer. Okay, so here um, control volume and control surface. Okay, these are all the two terminologies we are going to learn now, since if you take any one passage of fluid in which the fluid is entering and it is going out of the system continuously, during this flow of substance or working fluid, when it is moving through the passage, okay, if you want to analyze that particular fluid flow into that device, okay, where will you concentrate? Okay, we are talking about its system, surroundings, boundary and all, right? Okay, but here in these types of open flow devices, open systems, here continuously the fluid will be moving from here to there, from entry to exit. You have to take some area or region, in which you have to give your attention, okay, to invent something, right? So here you can able to see this rectangle. Okay, this rectangle part can be considered as control volume. Okay, you are reducing the area and you are concentrating, you are selecting a place of this rectangular box which is your control surface. Okay, control volume, bounded by an imaginary cover called control surface. Okay, that is any imaginary envelope is supposed to cover the control volume. Of course, for selecting any area means imaginary, that area has to be covered with the envelope, right? That imaginary envelope, which is existing around the piece of equipment. This is the whole equipment. Here where you are concentrating in this rectangular area, which is called control volume, and the envelope or the outer coverage of this control volume is called control surface. That envelope or imaginary or real envelope is called control surface. Okay, so control volume is the place where you are concentrating, and the boundary around the control volume is called control surface, which is an imaginary envelope supposed to have the outer coverage. Even in our body, the skin is the outer envelope which covers the whole body, right? Okay, above the skin so many layers are there. Of course, atmospheric air is also our extreme layer. It is also existing, but whether it can be taken as an imaginary or real, like that. Here control surface is enveloping the control volume, right? Okay, and another one more thing here, as we have already defined, the system is surrounded by the boundary, right? Boundary could be imaginary or real, or it can be flexible, or it is either fixed or moving. Okay, but here the control surface is not moving like the boundary. Okay, what is the difference between boundary and the control surface? Is control surface cannot move from its place. That is, you are viewing what happens to the fluid at this rectangular area. Okay, that is our purpose. You are analyzing this rectangle, right? Okay. Now, here let me come to definition. Control volume may involve one or more forms of work at the same time. So, here you can give any types of mass and any types of energy transfers can taken place in this control volume. If the boundary of the control volume is stationary, then the moving boundary work is zero. The work termed involved are shaft work and electrical work. Okay. Now here flow process, which constitute an open system through which the working fluid and enters and leaves the system, okay, from the surface of a system. Okay, so now here most of the engineering devices such as engines, turbines, heat transfer equipments, compressors, throttling devices are working as steady flow processes only. They are dealing with the flowing fluids. They are dealing with the flowing fluids undergoing some cycles, any of the cycles which we have studied. Okay, an imaginary envelope is supposed to exist around the control volume is called control surface, and the space that was bounded is called control volume, and surrounding envelope is called control surface. Okay, so another one more very important mm, concept is flow work or flow energy. Okay, why this flow word come into play with the open systems is, open system means fluid is coming in and going out continuously. The flow takes place. Okay. In our home, you are taking the water from the underground, right? Okay. How is it coming and coming out voluntarily from the underground, and it is individually without the aid of any work or power, is it going and filling on the tank, over tank, or without the aid of or help of anything that is coming away from the underground to our floor? No, we are supposed to give the power to change the direction of the spontaneous process. Why you are bringing the underground water to over tank is, from the over tank it is very easy to make the flow of the water to various places. But if it is in the underground, it is a view, you are supposed to, you are compulsory, you have to spend your power to bring that water in the reverse direction, because water flows from higher altitude to lower altitude always. Okay, so if some energy or power which we are spending to make the move of the fluid through this path, right? Okay, how we are making that movement? Okay, how much energy has to be spent to make the fluid to enter into the system or to leave the system? Okay, that is told by this flow energy. Okay, which is equal to P into A, nothing but the force which is required to overcome the pressure, taken by the amount of fluid to cross the particular area over the length of L. Then the product would become PV. Okay, so the flow work is equal to, or flow energy is equal to, product of pressure into volume. Volume pressure is nothing but force into area into over the length L. So FPAL will become PV. Okay, so flow energy is PV. Okay, let me continue this in the next video. Thanks for patient listening. Okay, meet you in next video. This is Dr. Suja.